Hello everyone, myself Rucha Anil Shinde. I am Assistant Professor at Jnanashri Institute of Engineering and Technology in Computer Science and Engineering Department. Today I am going to present a subject-specific environmental awareness video under the International FDP on Environment and Sustainability. So, for this presentation, my topic is Design and Analysis of Algorithms. So, in design and analysis of algorithm, more specifically, I am going to present on energy efficient programming code. So, let's start this presentation by getting familiar with what exactly is green computing. It is defined as the study and practice of using computing resources efficiently through a methodology that combines reducing hazardous materials, maximizing energy efficiency during the product's lifetime, and recycling older technologies and non-functioning products. So in short, green computing enables companies to meet business demands for cost-effective, energy-efficient, flexible, secure and stable solutions while being environmentally responsible. Green IT is about IT's contribution to reducing the whole organization's carbon footprint to support green computing. So now let's see energy efficient programming languages. For that, we must know what are the overall energy expenses. Normally, general energy consumptions as well as power and cooling costs are the energy expenses. Energy efficiency techniques were started on the hardware side to avoid a heavy drain on the CPU in order to preserve their batteries. But now it's trickled down into software development. The speed of program execution does not always equate with energy efficiency because compiled languages like C, C++, Rust, and other ranked as some of the most energy efficient languages out there. However, Java is also the one of the fastest and most energy efficient object-oriented language. Interpreted languages like Perl, Python, and Ruby were among the least energy efficient. As the researchers discovered, the CPU-based energy consumption always represents the majority of the energy consumed. Now, let's move towards the approaches to achieve the computational efficiency at the software side. Energy efficiency aims at minimizing the energy used to complete a task. The task does not necessarily have to be completed in a shorter time for energy efficiency. However, completing a task faster allows the computer to return to a low power state so that more energy can be saved. There are many different approaches available to achieve computational efficiency. Let's see one by one. So first is using energy efficient algorithms and data structures. The careful and targeted selection of algorithms and data structure can make a massive difference in the software performance. Energy efficient programming requires using high performance algorithms that complete tasks faster and allowing the processor to idle. Central processing unit is a dominant source of power consumption. Therefore, the optimization of the CPU can lead to significant energy efficient improvement. Software engineers should investigate efficient solutions for a particular problem in order to exploit this energy saving potential. Following example shows the great impact of algorithm efficiency on the energy usage of software. Suppose to sort some of the values, if we use bubble sort algorithm and at the same time suppose I will use heap sort algorithm. So within this bubble sort will take big O of n square time, whereas heap sort will take big O of n into log n time. So obviously choosing heap sort can have a massive impact on the energy consumption of ICT systems. Now the second one is efficient use of loops. Designing the loops by following some simple rules can lead to important energy savings. For instance, using unsigned integer counters or 0 as a termination condition for a countdown results in faster loops which use fewer resistors. Energy efficiency can be improved more drastically by loop unrolling. Now, loop unrolling is defined as combining the instructions that are called in multiple iterations of the loop into a single iteration. Loop unrolling reduces the comparison and testing overhead associated with the loop. Now, the third one is multi-threading. Single-threaded applications are inefficient and waste energy. Multi-threading can be implemented by time division multiplexing on a single processor. In this case, the processor switches between different threads. The context switching usually occurs frequently enough so that the user perceives the thread or task as running at the same time. Many modern ICT systems have multiprocessors or processors with multiple cores. These multiprocessors or multi-core systems can execute threads concurrently with every processor or core executing a separate thread simultaneously. Now, the fourth one is vectorization and the instruction set. Vectorizing the code instead of scalar C code using instruction set extensions such as SIMD can help improving performance and energy efficiency. SIMD is the abbreviation for single instruction multiple data and can be described as performing the same action on two or more pieces of data with a single instruction in order to exploit data level parallelism. Now, next is energy efficient libraries and drivers. Libraries contain optimized implementation of common algorithms. Utilizing libraries and drivers which are optimized for energy consumption can improve the energy efficiency of an algorithm. So, using these approaches, we definitely achieve energy efficient programming to support the green computing. Thank you.